This video is on lesson 4 out of the grade 7 module 4 book found on page 20. So in this one, we're going to start talking about percent in terms of increase or decrease. To open this off or to start this off, we're going to go with the open exercise. Open exercise says Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box below, sketch Cassandra's 5 rings. All right, I'm no artist, but I'll go ahead. I'll try sketching the 5 rings. There we go. So 1, 2, 3, 4, 5 rings. Notice I put some extra styling on them. Part B wants us to draw a double number line diagram relating the number of rings as a percent of the whole set of rings. So let's set up our double number line. There we go. So obviously I didn't write that by hand, but I want you to do your best and copy that down as close as you can by hand. So this double number line, we need to throw numbers in there. Percent being on top, number of rings being on the bottom. Now for this one, let's do the number of rings first. So 0, 1, 2, 3, 4, 5. I'm going to stop there for now because she had 5 total rings. So that means that 100%, I'm going to go ahead and put that above 5, 100% of her collection consists of 5 rings. And we can fill in the rest from there. Right here, 0% would go above 0 rings. And we broke this up into 5 intervals, right? 1, 2, 3, 4, 5. That means 100% gets divided by 5 so that we can see that each ring, or maybe I should say each interval there, is worth 20%. So we skip count by 20s. There we go. All right, moving along. So we drew our double number line. We're moving right through onto C. So what percent is represented by the whole collection of rings? What percent of the collection does each ring represent? Actually, we can just answer those two questions by doing the double number line as we did above. So what percent is represented by the whole collection of rings? There we go, 100% represents the entire collection of 5 rings. And then what percent does each ring represent? So again, remember 100% represents 5 rings. 100% divided by 5 gives us 20% per ring. There we have it. Each ring represents 20% of the collection. All right. Now we're going to get into example 1, which is where we find percent increase. So Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? So when we do this one, we want to use that percent equation, and we're going to use that to find the percent increase. So here I'll write the percent equation. There we have it. So the part in this case is the one additional ring. It says she'll buy another ring. So I'll highlight that. That additional ring is the part. So we'll put a 1 because she's getting one more ring. The percent as a decimal, we don't know that. So we'll put P. P equals the percent increase times now the whole is the original collection. So how much was in the original collection? Well, we know up here it says 5 rings. So down here we'll put 5. And there we go. Now we just were asked to find the percent. It's being multiplied by P, so we have to divide both sides by P. And we find out that 0.20 equals P. Well, that's not a percent, that's a decimal. To turn into a percent, remember you move it over twice, so that now we have 20%. percent as a decimal. So if she gets one ring for her birthday, her collection will increase by 20%. Her collection will increase by 20%. Which makes sense because she was receiving one ring, and we know that each ring represents 20% of the collection. All right, let's move on to this exercise 1. So exercise 1, John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? We're going to use that equation, quantity, which means, you could think of that as part, equals percent times whole to arrive at your answer. Then justify your answer using a numeric or a visual model. All right, so let's go ahead. Let's start writing that equation. There we go, got that down. Quantity is a little bit different of a word. We can think of that as the part in this case. It's just in this case, it's not that the 5 cards were part of the original, but that's the quantity that's being introduced or added to the original. All right, so our quantity is going to be the amount that he's either adding or taking away. In this case, he's adding them because he increased them. So go ahead, we'll put 5 underneath here. That was our quantity. Equals. And percent as a decimal, we actually don't know what that is yet. So we'll put P times, now the whole is the original whole, meaning how much the collection had to begin with, and that would be 15 cards. There we go. All right, so again, we're kind of back to getting P alone here. That means I would divide by 15 on both sides. And let's see, 5 divided by 15 gives you 0.3 repeating. So actually it should just be, there we go. It should just be 0.3 repeating. The 3 after it was okay, it's just that it's kind of unnecessary because we know that this bar means that the 3 goes on forever. All right, and that is equal to P. Now we want to turn this into a fraction. So we'll go ahead, we'll move the decimal back once, twice, remembering that this is 0.3333, and it keeps going on forever. So this as a percent will be 33.3%. 33.3 repeating percent. And as our final statement, we will say John increased his collection by 33.3 repeating percent. All right, down part B, it says, suppose instead of increasing the collection by 5 cards, John increased his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1 ring? In example 1. Why or why not? Explain. So let's kind of check that out. So we're going to set up kind of the same thing we did up here, except instead of 5, we'll put a 1. So we'll say 1 equals, and again, he still has a 15 card collection, so the whole is going to stay the same. And we'll divide both sides by 15. There we go. And when we do that, we're left with P is equal to, and 1 over 15 gives us 0.06 repeating, which ends up equaling 6.6 repeating percent. All right. So is that the same as when we increased, or when Cassandra's ring collection increased by 1? Well, no, it's not, because this is 6.6 repeating percent. In that case, her collection increased by 20% when she added one more ring. So what's the difference here? The difference is that the whole number in John's original collection was 15. The whole number in Cassandra's original collection was 5. So, because the whole collection started out at different amounts, when you increase both of them by 1, that'll be a different percent increase for each of the collections. So we'll say, no, their collections had different whole amounts. So one part of each is a different percent of the whole. So part C, based on your answer part B, how is displaying change as a percent useful? It is useful because change as a percent allows us to compare part to whole increases or decreases in one number, and that one number is the percent. We know that if something went up by 15% and something went up by 20%, whatever went up by 20% had a greater increase compared to what the original whole amounts were. All right. The last thing we'll do in this video is this discussion. We're going to look at this sentence and kind of turn that into some equations. There's two different ways to think about it. Let's look at the sentence first. A sales representative is taking 10% off of your bill as an apology for any inconvenience. There's two ways to think about it. That's why we have two columns. The first way is that 10% of your bill is subtracted from the original bill. And that's kind of self-explanatory with the taking 10% off. That means you're subtracting 10%. So down below, that equation will kind of go like this. The original bill is the whole, which is 100%. And the new bill will be, we have new bill equals, we're going to take the original bill and we're going to subtract, which subtracted from, we're going to subtract 10%. To find 10%, we're going to take that as a decimal, which is 0.1, or we could put 0.10, doesn't matter that much. And we're going to multiply that by the original bill. And there we go. So we're doing the original bill minus 10% of it, because remember, you find the part, so in this case the 10% of your original bill, by multiplying the percent as a decimal multiplied by the whole. All right. So that would be one equation to suit this situation. One way of thinking about it. The other way of thinking about it is that you are paying 90% of the original bill. You're not paying all of it, because again, they said that you're going to take 10% off, and that's, so 100 minus 10 gives you 90%. So that, in that equation, the original bill is still the whole. And then to find your new bill, or the bill you have to pay, you could save yourself a little step, and you can just do 0.90, 90% multiplied by the original bill. Saves some time. So you have two choices for equations, two different ways of thinking of it.